Thank you. Before I get started, I just want to thank all the organizers of this conference. This has been fantastic. I've had a really good time these last few days. All right, so I am Louis Montes, Montes Lou on most social network things, Twitter and GitHub and wherever else that handle is still available. Like Alex just mentioned, I run IceDev in the US. We do full stack JavaScript, so Node.js, React or whatever up front. And we've actually gone a little further than that in recent years, going past the browser and into hardware, IoT-related projects. So we're an Internet of Things company mostly lately. So just this past Consumer Electronics Show in Las Vegas, there was a bunch of really cool products released with Internet connectivity. In fact, one of them you could, at least one of them, you can use your iPhone, well, only your iPhone, no Android support, and search for their product, install their app, accept permissions, sign up, discover on the network locally device, press a button on your screen, and a button would be pressed in the physical world right in front of you. So, what a time to be alive, right? All right. So, of course, IoT has been mostly marketing, but there is actually some tech that's come out of this, right? So, recent years, there's been a few things that have helped us to actually realize some of these amazing products. There's been a whole lot of really inexpensive boards, right? Arduino, like over the last decade, Raspberry Pi, and these things are really easy to get started with, so we can prototype things really quickly. It also helps that half the people in the world have a supercomputer in their pocket with an internet connection. That helps out quite a bit for IoT as well. But one of the things I'm really interested though is just sort of the ubiquitous bidirectional communication, right? We've historically, especially with the web, have made requests, got responses, but we have been doing a lot more server push in recent years, and it's gotten a lot easier to do it. So that's a big part of this. But let's start off with the embedded hardware. So we are front end, or at least since this is the front end half of the conference, there's probably a lot of JavaScript developers in here. And anybody that wanted to do JavaScript and robotics, or little IoT things, has probably started here. So the first commit to the Node serial port repository was September 7th, 2010 by Chris Williams. And this sort of started the whole NodeBots movement. So let's say, before I get there, with Node serial port, it's a very popular project now. It's got a lot of contributors. But what I really like what they did is a really simple API. So this should look familiar to anybody who's done Node. It's an event emitter, right? So we can, if we want to read data, or at least data events as they come, to us sort of asynchronously, we just add an event listener, so on data, and we get some data every time that comes across the wire. And if we want to write data, we're typically sending like a buffer, a node buffer, or a uint8 array, and we just have a series of bytes, and we usually express those as like hex codes, so or 0 to 255, or if you want to be real specific there with bits, you can do that as a literal in JavaScript. So let's say I want to connect using JavaScript, using Node.js specifically, to a piece of hardware like an Arduino Uno. So Node serial port is perfect for this. And the way this has been working historically is we have our Node program fire up, establish a connection to the serial port, and the first thing we do is we ask the Arduino what its version is. And that version is the version of Fermata. So this is a common sketch that we've been using to automate these pins. So every one of these Arduinos or one of these boards have general purpose inputs, outputs, so we can turn switches on, we can listen for changes in current so that we can connect a sensor, things like that. But Fermata is a really good way of doing this, especially, and it doesn't really have to be Node, but this is really easy to do with Node. And of course, this thing shoots us back a message asynchronously of what its version is. And then typically the process is, okay, Arduino, what can you do? So give me a capability query. I'm going to do a capability query, and you're going to string me back all the pin descriptions, like, pin 13 can do digital in and out, and, pin 3 can do pulse with modulation, like variable amounts of current going out, things like that. All right, sweet. We've got a description of the pins. We've sort of bootstrapped this connection, and we could do something like, yay, turn on pin 13. So the reason we always do this is the hello world of electronics, right? We need to see that something actually happened from our JavaScript code or whatever language to the physical world. And that's why turning on an LED always seems silly, that we're making all these steps to flip a light switch, but it's to show that we have connectivity and that everything's working. Of course, we don't want to send all those bytes and know how to do like what the things are. In those last slides, those were the actual bytes that are going across for Fermata, but that's a lot to do. So fast forward a couple years after Node Serial Port, and Rick Waldron made the first commits to the Johnny 5 library, which is basically an abstraction for doing robotics. And this has become a very popular project, over 100 contributors. It's really good stuff. And instead of having to know what to send down the serial port exactly, we've got some abstraction like create a board. When that board's ready, maybe create an LED and then blink it. Or have a sensor that gives us the temperature. Or have a servo motor to move a robot's arm. And we have like high-level APIs for all this. And fast forward a couple more years, and Rick did the first decoupling of making it something specific to Arduino and allowed for other boards. So he made the Galileo, which was an Intel board. He got that to work. And then everybody else sort of jumped on board. People all over the world were creating plugins, these I/O classes, that can go into Johnny 5 to support all kinds of other hardware. And some of these boards were a lot more powerful than, say, an Arduino, so we could run Linux and Node.js directly on the board. So they wouldn't have to be tethered at all. The robot logic is all happening right there on the embedded platform. And over these last few years, the movement of Node bots, Johnny 5, all of this, there's been RobotsConf, there's been a lot of this stuff at JSConf, and the movement has grown quite a bit with people doing JavaScript and robotics. And once a year, there's International Node Bots Day. So all over the world, people get together and build robots. And this is the event that happens over in Phoenix. And there's been 4 of them so far, so 4 years in a row. We started off just doing the tethered Arduino thing to Fermata, moved on to Wi-Fi, and eventually Bluetooth. So it's been progressing, and it's a whole day of robotics, and at the end of the day, we smash the robots into each other. It's kind of fun. And there's been a whole lot of creativity that's come out of that as well. So people start by putting the robot together and getting the thing to move, but then they want to do something like, oh, I want to put a web dashboard on front of this thing so I can have some buttons and things to to build a UI more than just command line node. And so typically we'll have a node server, right, like Express or Happy or something like that, and that takes requests in, fires up Johnny 5. You build a dashboard, and then you're like, okay, but I want this really, interactive. I don't want to just make AJAX calls from my front end. I want to do like have sensors push, event source down, or use socket I/O, some web sockets to do things in real time from my dashboard to my node process running Johnny 5. Or MQTT, which is another IoT type transport to do publish and subscribe back, over a web socket or just a direct TCP socket back to that. And So that's a great start, and what I really like about progressive web apps is, there's been a couple of great talks already on this, so I'm not going to go too detailed onto what the progressive web apps are, but we already know at high level there's a service worker that intercepts things so that all network requests can go through that, so we can run the things offline. We can put a manifest into things, so we can get an add to home screen button. We can do push notifications, so we can have like a server send a message to our service worker, wake it up, maybe bring up the page, but it could also send an encrypted payload as well. That used to be a thing where you just send a notification, and then the web page or the service worker would tell the web page to make a request to get data to come back, but we can just do that all as one thing now. And they're supposed to also be fast, secure, and responsive, and this is really good, and we can just add that right now to these existing things we've been doing, with Johnny 5 and IoT. But that just kind of gets us to where native apps are in a way, right? Like that is not pushing it forward as much as like catching up to native Android and iOS applications. But there are some things that the web just does better, at least in my experience here.
Not just the deployment and not being in a walled garden or anything like that, but what's already been talked about as well is Webrtc. Now, this is actually a really big deal, and this is why I've heard a couple of talks here about this already, and Nikita's was really good and really detailed, and this is not detailed. But just real simple story here. Imagine we got, we'll call him Peter, and Peter wants to send something really important over to his good buddy Varys. Now, Peter doesn't really trust like Facebook Messenger or Google Chat, so he doesn't want to go through somebody else's network to send this important information over. He wants to just send it directly to him. It was discussed before. There are some things that have to happen. We can't just go straight, peer-to-peer. We have to go through at the very minimum. We have a stun server, which is how our browser on one side of the internet figures out how to tunnel out, and so he gets a response back from the stun server. And what does that look like? How does he take that stun message, use his browser to create something that he needs to get over to Varys? So he creates this offer. It's about 5K worth of JSON, and I don't understand everything in this. But what's important is he needs to get that over. So we talked. There was talk earlier about a signaling server. It doesn't necessarily have to be a server. In fact, while a WebSocket, like between two peers, could be a really quick way to get this 5K over to the other person, it's not nearly as fast as a Raven. So a Raven can have that message bundled up and go over to the other guy. Varys, in this case, can transcribe that message. He could put that right into his browser, who talks to a stun server, and gets an answer. That answer looked very similar. Another big blob of JSON. That has to get back to Peter. Now, this stuff could be all, like I said, out of bound. That was what was mentioned earlier. But it doesn't have to be an actual signaling server. It could be anything. And he doesn't like Ravens. He's going to send this back over Gmail so he could just copy and paste it. And yay, Peter is able to establish now a direct link. And just like we had sort of the bidirectional communication with serial port, like we have with WebSockets, on message, very important. Either one of them could read events that come in. And of course, either one of them can send things out. So very helpful, and very helpful for IoT applications and sort of expanding what we're able to do with the web using peer connections. But okay, what does that got to do with putting browser robotics together? Just think of all these things as a toolbox, right? To connect every little piece. But can we just take Johnny 5 and use Webpack or Browserify and just expect it to work and talk to a piece of hardware in Arduino? Typically, what do? We have some problem like this with the web, so we'd want to wrap it in some sort of thing and deploy it to a store to have more access or something, right? Well, you might not need to do that. You might not need a wrapper. You might be able to do these things directly from a browser. Okay, so anybody heard of MIDI? Old school, right? MIDI's great. And MIDI's for making music, right? MIDI is for playing notes or receiving notes. It is for that. But what you can do is emulate a MIDI device. So there's a whole bunch of different Arduinos that can emulate any USB peripheral with just a very small amount of code. Some of the newer Maker Arduinos, the older Leonardo Micro, they can all be any peripheral, USB peripheral you want. And there's a very easy-to-use Arduino library to make USB devices, but also another layer on top of that to, say, be a MIDI device. Okay, but the MIDI protocol is actually pretty constrained, right? We know there are certain things we can do, like play a note on this channel, with the first byte, which key, 0 to 127. What velocity we're going to strike that key. So if we're like playing a piano, it's on this channel, this note, this velocity. But it turns out, even though we're constrained to what those bytes are allowed to be, that range, the peripheral that we want to talk to doesn't really care. But if you think about it, if we've got like 64 values in the first byte that we can be, that's 6 bits of arbitrary data. 0 to 127 in the middle, 0 to 127, another 7 bits. We got 20 bits to play in, because it doesn't actually have to be a musical instrument. And what's really nice about this is since this seems like such a benign thing to do, to just send notes or listen for notes, you can usually get away with the browser not even prompting you for access to MIDI ports, which is very handy. And just like the other APIs that I was saying, where we have a read and write, this is just as simple. It's not the typical event emitter, but it is, we're putting a callback of what happens when a MIDI message comes in. We got data, and our output send takes yet another array buffer, or another uint8 array or a buffer of bytes. However, these need to be in that format, right? They need to be in those ranges, or they'll throw an exception in the browser. The thing about doing that low-level bit manipulation is that I, for years and years, didn't ever have to do that. It didn't help me to make an enterprise application to know how to move bits around. But some people have been doing this, and they've made some really cool libraries on top of it. So if you just take the time to figure out, okay, yeah, this bit shifting, and I don't want to do all that, but if you just spend a little bit of time on that, you might be able to enable some piece of hardware that is very constrained and that you really need to worry about just what's going into it. So the stuff that you might have done in computer science that didn't have a whole lot of use, very useful if you're doing any of this robotic stuff. Okay, so if you don't want to use MIDI, although MIDI's super great for this right now because MIDI is available, it's been for a few years, at least in Chrome. There's an open issue on Firefox, and there has been some work. Actually, just 3 weeks ago, there was a commit to do input stuff. It's not production ready yet, though. WebUSB, however, as of Wednesday, is stable in Chrome 61. So we can use this. So what is WebUSB? That sounds like super dangerous, right? Like just generic WebUSB access. Well, there's a lot to getting to the to a USB port through WebUSB. You have to be on HPS. You can't even start until you answer a dialog that's popped up. That dialog is prompted by a DOM click. So you can't just load a page and have it connect. You have to instantiate that from a user interaction. You also have to put filtering criteria of just which devices you're looking for. You have to be real specific and say it's this particular vendor and product ID. So, but once you get past all of that, if you're building for a specific device, this isn't too bad. In fact, all of those devices that I was just showing that can do MIDI can also do this WebUSB, and then you're not constrained to just certain bytes. You just get to full blast bytes back and forth to a device from the browser. And this is a little bit more complicated because there's more options on how you send things. Like there's bulk transfers and more transactional things, but in the end, we're really just reading data, sending data, input, output, just like everything else. And we're dealing with arrays of bytes, just the same. Okay. So Bluetooth, another way of connecting. Now, Bluetooth historically, if you've never done Bluetooth for robotics, Bluetooth has been about pairing your phone to your speakers or something like that, right? These are older Bluetooth profiles. But as of Bluetooth 4, which has been around for several years now, we've got the ability to do Bluetooth low energy devices. And this is actually very, very different than the old way of pairing. Bluetooth low energy devices let something go to sleep for a long time, wake up, do a thing. One of the things that they go to sleep for and wake up is to beacon. So imagine this little tiny device running on this coin cell battery, sleeps most of the time, wakes up once a minute, or whatever interval you configured it for, and I don't know, shoots out a URL like some people in the audience tend to do. And that is called the physical web. It's using a byte format called Eddystone. It's basically encoding a URL into this packet that's being advertised every so often. And this is actually really cool in that it gives us a starting point, right? So if you've got this URL that's coming up and it just shows up on your phone out of nowhere, that might be because there's a piece of hardware that we might want to interact with. And we can take that a step further. Cool, we're at this URL. We've opened up this, say, progressive web app to talk to something potentially directly. So the Bluetooth low energy stuff, unlike the older style Bluetooth, Bluetooth 4 on up, has what we're calling Bluetooth services. So imagine something like a heart rate monitor has got a heart rate service. It can have multiple services as well. Now, these services have characteristics. A characteristic is like where the data is accessed at. So if a service is a heart rate monitor, so we might ask for subscribe to notifications on heart rate changes. So we're able to read like events in real time, or we could potentially have a characteristic that lets us write something back. And this heart rate monitor is just an example because it's one that's sort of already known. We're using like service IDs that are common. But we could make these up. These could be anything. So this is like an arbitrary communications channel that doesn't have to be something that, like some approved vendor specified. You can grab a Bluetooth Arduino and just say, I'm going to create a service that does this thing. And if anybody's done Bluetooth Low Energy with Node, they've likely been using Sandeep Mystery's project called Noble. And Noble's great for Node, very easy to use API. What I like about Noble as well is since a lot of Node projects, like the Rolling Spider, the little drone that's web Bluetooth, all of these things that were written against the Noble API, there's now a shim, so you can take your Noble Node.js Bluetooth code and get that to run on top of web Bluetooth using like Browserify or Webpack. And okay, so that's pretty cool. We can establish a connection. This also, when we're using web Bluetooth, when we want to establish a connection, we have some similar constraints to what we were doing with web USB. So with web USB, it has to be an SSL side or HTTPS. There has to be some user interaction. We have to specify just which services we want to talk to as well. A dialog will come up, and we'll connect to it, and then we'll actually pair with the device. And once we're paired, it's a one-to-one thing, a device connected to a computer, to a phone. And once we have one of these service connections and we sort of iterate through its characteristics, we can ask for on data or write, just like the event emitter, just like serial port. And in fact, a lot of these Bluetooth devices are using a common service called Nordic UART, and that basically ends up being just like serial port, except it's wireless. And there is a Bluetooth Low Energy serial port implementation that we could plug into Fermata and do the robotics that way if we want to. Okay, so here's another one, and this one's super, super early. So this is very subject to change, I imagine. But there is a W3C spec on top of it, and that's near-field communication. So this is, like I said, it's really early, but yet another way for us to take a device and potentially send arbitrary bytes between a couple of devices, right? So we can have our phone, which has an NFC reader, and it could also project NFC messages. What does that look like? If we want to expose some bytes to something else that's going to pick those up, we're using Web NFC push. So Navigator NFC push, hello world. If something wants to read that, so on the other side, it can set a watch to listen for NFC messages that it gets close to, right? So NFC watch, do something, all promise-based, and that should work pretty well. Okay, so I went faster than I should have, but I'm going to start doing demos. Hardware demos are the dumbest thing that you could possibly do as a speaker, so I'm going to do the dumbest thing possible as a speaker and do a hardware demo. A little bit of setup here. Those Leonardos, those things that can do USB peripheral, this is a knockoff, a Pro Micro that was like a $3 version of that, but it's able to use a library, so that's pretty cool. The top right thing, that is a accelerometer from a Tesla. Tesla is one of those other boards that's supported by Johnny 5. What I really like about what they did is those modules, yeah, they fit really well into a Tesla, so they're really great for a Tesla, but they're also using a common standard to communicate, something called I2C. It's I2C, look it up. Anyways, it's a way to connect just microcontrollers to microcontrollers, integrated circuits to integrated circuits. And we can take the accelerometer data off of that and push it into this Arduino. Now, why do I have a QR code? Because there's another new sort of experimental web API that I kind of want to show off as well. Jen, in her talk yesterday, showed what they were doing with faces. And faces are really cool because you get, the position of the face and potentially where the eyes and mouth are at, and like a bounding box around somebody's head. What I like about the QR code part of the shape recognition API is you could have data in there, right? So that's cool because we could have position, but we could also have data. And if we're doing IoT things, we typically have our data described as our devices described as a UUID, right? If anybody's done anything with IoT, it's basically 16 bytes. It's this big ugly number. If you're going to do that, don't put the dashes in it. For some reason, we do like 32 characters and 4 dashes, and I don't know who came up with that or what the reasoning is, but 36 characters is just past the threshold of cool QR codes and into the really nasty high-resolution ones. So just take out those 4 dashes, and then you got an easier-to-read QR code. Saver tip for the day. And the face here, this little robot, so QR codes are kind of ugly. UUIDs are kind of ugly. But hashing things into cute robots are really cool, right? So if we decide, these bytes mean this color and all that, so there is an algorithm in this demo that if you put any QR code, you get a somewhat unique-ish robot face out of it. Okay, a little bit more setup here. Since this is front end, video tag, everybody knows what a video tag is, an HTML5 video. Inline styles, I'm sure somebody will yell about me putting an inline style there, but I want to put the video in the back. Canvas in the front, right? A little bit more demo setup. 3JS was discussed earlier. 3JS is awesome. 3JS has this trick you can do where you can say the alpha on your renderer is, you can make it transparent, and you can set a clear color. I'm not sure why it all works like this, but what this does is gives us a 3JS without a background, right? So a transparent 3JS. And it's a little bit more setup. The Barcode Detector Api, which I've gotten here, can also run in a web worker. So even if it's a CPU-intensive task, we can background that in a thread. With Chrome 61 also, Canvas, off-screen Canvas was added, but we don't need that for this. All we need to do is get our image data into the web worker. And that image data, if we post to the web worker, is processed. There's also, in this particular demo, a fallback. So I don't want to use the fallback, though, because the only good QR code scanner that I found that's completely JavaScript-based doesn't give quite the same effect. It gives us 3 points. The one that's built in gives us 4 points around a thing, and that makes a difference for what I'm going to do here. Although the other way still works, but the native barcode detection experimental works better. Okay, so that was way too much setup for this demo. But, okay, so like I said, video, we could just use get user media to put into that video. And we can use the QR code scanning. Now, what this is doing is, this is not a real AR framework, right? Like AR.js, go use that. There's another one that just came out by Google. The stuff that I've seen Jerome had to do with AR.js is really cool. But what this is doing is, if we're going to use a marker like AR.js is doing, maybe that marker should be a little bit more significant than just, hey, there is a thing here. Well, that thing could correspond to something that's actually a device that we can read and write data to, right? So if you have something, say, as simple, oh, also, this isn't a plastic box because I've done demos before without plastic boxes. If you're ever going to do a hardware demo, put it in a plastic box or you'll totally screw it all up. If we take accelerometer data and then we encode it as MIDI bytes, then we can take sensor data, match that up with something in the real world. So just think of this as sort of the start of, okay, we can have IoT devices, either beaconing or, tethered or whatever, that are emitting data that correspond to something in the real world that we're able to then change the display with augmented reality. Right, and all of this right here is being done without any major toolkit other than 3JS. But if you don't even have to use that if you know how to do the really crazy WebGL stuff without 3JS. So it doesn't really need much more than we're scanning a QR code and finding that position. There was a little bit of math here that I had to learn to do that. Right, like we're taking 4 points, but I'm able to get
angles and stuff out of it, because we can translate those 4 points into 3D coordinate space with something called a posit algorithm. I didn't even know what to search for, but I managed to eventually find that. So anyways, that's about the gist of it. So just think about potentially some of these tools that we have, this sort of toy box of things that we have now in browser that we can just build things on top of and stitch together IoT, AR, web VR, all of that. It's just been a lot of fun lately, kind of connecting the pieces. That's all I got.